Hello, good morning, guys. Can you hear me?
Yes, we hear you perfectly.
Great, great. Thank you. Thank you, everyone. So, hello, everyone. Welcome for attending and welcome to attending to the session. In this first session, we are going to introduce to you the Hedera technology and the Hedera ecosystem. So, I just want to insist that this session is very crucial because it's going to introduce to us the basics of developing on top of the Hedera network. So it's really important for the beginners and for the and for the future developers of Hedera ecosystem. So I want to introduce myself first. My name is Ala Shahtour, and I'm software blockchain developer at Latency Under Blockchain. So I'm going to present the Hedera ecosystem for you. And of course, if you have any question, please don't hesitate to open your mic and go for it. Okay. So yeah, at first I want to hear you guys who have any idea about the blockchain technology. I want to hear from you if someone of you have any idea about the technology of blockchain. You just can write on chat. Guys, okay, data transfer system, perfect. Okay, we can say it's a data transfer storage at first, mainly the most known thing about blockchain, where we can storage our data securely and perfectly. So yeah, we can say like it's a data storage system at first, and also we can transfer data using blockchain, of course. Or we can also to correct it we can say data value transfer, because now as you can see, we can like create tokens and we can give value to the tokens, and also we can transfer those tokens between us. Okay, so yeah, that's one of the things that we can do on top of the blockchain. So blockchain technology is a way of storing data that makes it very difficult to change. Perfect. That, yeah, it's uh, it's almost correct. So um, the blockchain technology, it allows us to store data, and it allows us to store any information that we want, and it makes us also it's like nearly impossible to change um, one of the already stored data on the blockchain. So yeah, thank you very much, Amani. Also, thank you, Yassine. Okay, so is there anything else you can add? One of the characteristics of of blockchain, yeah, cryptocurrencies. It's one of the use cases, or the most known use case that we can build on top of the blockchain. Perfect. Thank you, Luai. Ensure record transactions across multiple computers. Perfect. Yeah, thank you, Aya. It's like we call it like the transparency. So it records all the transactions and we can return to those transactions anytime we want. Thank you, Aya. Ru'a, it's a technology that enables the secure sharing information. Yeah, exactly. It's yeah, it's technology that we can share with it all the information between us and other users. So, and also we can call it, it's a distributed technology. Okay. So one of the characteristics or one of the features of a blockchain is the distribution of the information. Okay, so the information is not located in one place, it's located in many places. We call them, technically we call them nodes. Okay, so we are going to go more deeper into those words and all of those technicals. Okay, yeah, thank you everyone, thank you for your contribution. So let's start now, and I'm going to share my screen. Okay, just a second. Okay. So can you see my screen, guys? Perfect. Okay. Yeah. So let's start. Um, okay. So as we discussed, that blockchain is a distributed technology. I just want to tell you guys that there is a family that called DLTs, which means the distributed ledger technologies family. Okay, so this family contains five type of technologies or five different types of technologies. The most known ones are blockchain and the hash graph technology. Okay, so DLT is a distributed ledger technology, and the blockchain is the most widely known type of DLT. Okay, so the blockchain is one of the family of DLTs, and all the family of DLTs share the same goal, which is the distribution of data. Okay, yeah, that's exactly the goal of all the DLTs technologies. Um, Okay, so just guys, if you have any question, I can see the chat, so you can directly open your mic, okay, and just say it, okay? Perfect. Um, so blockchain is the most widely known type of DLTs, and also DLTs represents a trusted store and of distributed data. So we're like it's a technology that makes us able to distribute data in a trusted manner. Okay, so we trust that the system or the technology makes the data secure, and we can change it whatever it happens. Okay, yeah, that's exactly the idea, and its replicated nature makes data tampering very difficult. So yeah, as we said before, that the nature of the technology makes it difficult or impossible to change any information that is already stored on the blockchain or on the DLT technology. Okay, so and also I just want you to know that there is types. So there is in the family of DLT, there is five different technologies. The most known is the blockchain and also the hash graph. So by the way, the Hedera technology, it's not a blockchain, it's a hash graph. Okay, it's one of the DLTs, but it's not technically like a blockchain. So we're going to see later the difference between the blockchain and the hash graph. Okay, yeah, and the types of the DLTs, there is like we can say that there is two types. So the first one is the private permissioned DLT, okay, or private permissioned network. So what we mean by private DLT or private network? So when we say private network, it means that the data, the access of the data is private. So there is like only some users or some addresses have the ability to access to the data. Okay, yeah, that's exactly what we mean by private. Also permissioned, it means that the validation of the transactions, okay, or the validators of the transactions are selected one by one. Okay, yeah, and also there is the public DLTs, public permissionless networks. Yeah, public network. What we mean by public network means that the data or the information that's stored on the blockchain, we can access it. Everyone can access to it and can have an idea about it. Okay, that's exactly the what we mean by public. And also permissionless, it means like anyone can validate or can be a validator on that network. So let's take an example, for example. So, for example, one of the private and permissioned ledgers are like I think it's a Hyperledger. Okay, Hyperledger. It's one of the private permissioned networks. Okay, and also an example for public and permissionless network are Bitcoin and Ethereum. So Bitcoin is the first network that is public and permissionless networks that blockchain networks that exists in the world of blockchain. Perfect. So now let's focus on Hedera. So Hedera, guys, I want you to know that Hedera is a public DLT. So it means that all the information that already stored on the Hedera network, we can access it. Anyone can access to it anytime he wants. Okay, and he can extract those information from it. Okay, yeah, that's exactly the idea. And it's a permissioned network, so it's public and permissioned. It's not public and permissionless. It's public and permissioned. It means that permission, it means that Hedera select their validators one by one. Okay. So yeah, that's exactly the idea. And we are going to see exactly who are the validators of Hedera. Okay. So for now, is there any question or everything is clear, guys?
For me, it's clear, sir.
Perfect. Perfect. Thank you. Thank you, everyone. So yeah, let's continue for now. Also, I just want to focus on the evolution of storing the information starting from before like 1970 and until now. Okay, so before 1970 we used to uh, like and register all the information on papers and on all documents. Okay, and when the computers are invented in 1970, um, we moved to register all of our information on top of the on the computer. So it provides us the speed of accessing the information. Okay, but the issue here that the information is located in one place. Okay, we can't share it with other like computers or something like that. So with the internet starting from 2000, it gives us the ability to share the information between like one machine to another, and so it keeps the feature of speed, and also it gives us the feature of access and collaboration. We can collaborate with storing the data or with creating a document or something like that. Also, starting from 2009, which is the year that Bitcoin was invented and was created. So the trust era was created. Okay, so now we can ensure the speediness of storing and accessing the data. Also, we can ensure the access and the collaboration, and also we can say that we add the trust of storing the data. So we trust that the network it's not going to manipulate the information. Okay, so as you can see, or as you know, one of the examples in the internet era, it's what like we can say the and like for example Facebook or Instagram, our information and our data on Facebook and Instagram are not technically for us. Okay, they technically own our data. So at any time they can delete your account, they can ban you, they can do everything they want because they control the server. Okay, so the server of the application, they control it, they have access to it, they can do everything they want to it because the all the information and all the data are stored in a centralized server. Okay, the same with banks. So our data and our account transactions, they are stored on their servers, so at any time they can be hacked. Okay, so we can be stolen by a hacker. Okay, or also they can like ban our account, or they can yeah they can ban our account, and we can no more get access to our money. Okay, yeah, that's exactly the idea. But with Bitcoin, there is no one have the ability to control the network. So it's really decentralized, so it's controlled by all the nodes connected to the Bitcoin network. So which makes it very difficult and nearly impossible to to change any information that already stored on the network. Yeah, that's exactly the evolution of storing all the info or the storing data. So now let's move and let's focus starting from 2009. So as I told you, in 2009, Bitcoin was created. So it's like provides us it's decentralized trust and programmable money. So Bitcoin, guys, it's only used to make some cash transaction or some money transactions. Okay, so we can't store all the information on top of Bitcoin. We only make transactions of Bitcoins on that network. So it means that the Bitcoin network only store the information of transferring tokens. So if you open the network of Bitcoin and you want to access to all the transactions of Bitcoins that already exist from 2009 until now, you will see only transactions of Bitcoins. So you are going to see the sender, which is like an address, to the receiver, which is another address, the amount of like the amount of Bitcoin of the transaction, also the time of the transaction. That's all the information that you are going to see in one single transaction on Bitcoin. And starting from 2004 and 14, like the Ethereum comes to life. Okay, so it gives us the ability or the feature of programmability. So it means like we can now make programs on top of the blockchain. So with Bitcoin, we only make transactions of money or Bitcoin. And with Ethereum, we can add the programmability feature. So we can develop any program we want. So for example, let's say I'm going to program an application on top of a blockchain that makes transactions when it executes, or I can add some conditions. If that condition is met, the transaction is going to be executed automatically. That's exactly the idea of smart contracts. So we can develop smart contracts, and those smart contracts we can deploy them uh, integrating them in the blockchain. And when this condition is met, the transaction will be executed automatically. Yeah, but Ethereum in that time faced a lot of problems, which is like some scalability problem. Let's say, for example, one of the scalability problems faced by Ethereum is the transaction speed. So the transaction execution in the Ethereum takes around 15 seconds. When we say 15-second, guys, it's really a huge time. Okay, so for example, if I want to develop an application of or gaming application on top of Ethereum, I can't choose Ethereum as the target target blockchain that I'm going to build on. Okay, because for example, if I want to move my avatar, okay, I will like wait 15 seconds until my avatar moved. Okay, so which is not scalable at all. Okay. Also, the fees of the transaction is in Ethereum sometimes becomes high. So we attend in 2021 or 2022, I think, we attend that the fees of transaction becomes $136 per transaction. So it means, for example, if I want to send $10 from one user to another, I need to pay $136 for it, which is not acceptable at all. Okay, yeah, that's one of the difficulties uh, faced by Ethereum, and all the networks created after Ethereum. The goal of those networks is to scale the Ethereum, okay, to solve the problems faced by Ethereum. And one of those networks is Hedera Hashgraph, okay. So with Hedera Hashgraph, we are able now to it's of course it's programmable, okay. and also it's scalable. It means that the fees are very low with Hedera. We were talking about $136 with Ethereum, but with Hedera we are talking about like $0.0001 per transaction, which is like a huge changement with Hedera. Also, the transaction speed with Hedera is between 3 and 5 seconds for the execution of the transaction. Also, the number of transactions per second, it means the treatment of the number of the transaction per second is very high in Hedera. So Hedera can treat 10,000 transactions per second, but with Ethereum it can only treat 20 transactions per second, for example. Okay, yeah, it's like it's like very scalable Hedera comparing it with Ethereum. Okay, so yeah, for now, is everything clear, guys? So is there any question?
No, it's clear.
Perfect. So yeah, there's no question. Let's move on. Okay, perfect. So yeah, now the difference between blockchain and hash graph. So as you can see, guys, um, this is the architecture of a blockchain, and this is the architecture of hash graph. So as you can see, the blockchain, it's like blocks linked to each other. Okay, so the design of the blockchain makes it the execution of the transaction is slow. Okay, so for example, let's take Bitcoin. For example, Bitcoin, the creation of a new block, it takes 15 minutes to create a new block on top of the Bitcoin blockchain. Okay, also we need to make a lot of effort in order to create a new block on top of the blockchain. So for example, as you know, in Bitcoin we need to mine Bitcoins in order to add a new block on the blockchain. So to mine Bitcoin, it means like we need to consume a lot of electricity in order to create a new block on the Bitcoin blockchain, which is like costs a lot of money. Okay, but as you can see, the hash graph design, like every node is connected to each other. Okay, so if you start from this node, you can directly get to this node. You can have a way to get to this node. Okay, yeah, that what make the Hedera hash graph very fast and very scalable. Okay, and we are going to see a demo after that, where like validators, uh, how they make all the process in order to add transaction on the hash graph. Okay, or yeah, on the hash graph technology, and how the transaction is shared like in a fast way with all the nodes. Okay, so yeah, now let's focus with Hedera. Okay, so Hedera is a fully open source, permissioned, public distributed ledger technology. So what we mean by open source, it means that the code of Hedera, you can access it and it's accessible by everyone. You can check the code of the Hedera. You can like see all the code of Hedera. You can like open your GitHub and write Hedera network or Hedera hash graph, and you will find the repo of Hedera, and you can access to the code of Hedera. Permissioned, it means, as I said before, that the validators of a Hedera network are selected one by one. Okay, public, it means like everyone can access to the data stored on top of the Hedera network. And distributed ledger technology, it means it's one of the distributed ledger technologies family. Okay, so it's running the fast transaction is very fast on top of Hedera. Fair, it means like we ensure the fairness of the execution of transaction. We are going to see exactly the fairness of execution of the transactions in the demo. Okay, in just a while. and secure hash graph consensus algorithm. So it runs a specified consensus algorithm that makes all the transactions stored perfectly and securely on the Hedera network. Perfect. That's exactly the definition. And also, I need you to know that Hedera provides tools to the developers, okay, in order to make the development on top of Hedera is developer friendly, okay. So it makes it easy to us to develop applications on top of of the Hedera network. So it gives us like the services of token service. So this service is allows us to create tokens. What you mean by tokens is like, for example, fungible tokens or non-fungible tokens. So by the way, guys, do you know exactly the difference between fungible tokens and non-fungible tokens, which are NFTs? Have an idea about it?
The NFTs.
Sorry, can you just repeat?
You talked about the NFTs. The question is,
Yeah.
what is
So yeah, the
NFTs?
difference between NFTs and yeah, it mean for non-fungible tokens and fungible tokens. What are they exactly?
I guess the NFTs use images, and it's not the same way to store NFT or
Okay.
other thing. I guess this is
Yeah.
the difference.
Okay. Okay. Thank you, Yassine. Thank you for your contribution. So actually, Yassine, the difference of NFTs and between NFTs and fungible tokens is that NFTs makes the asset unique. Okay. So the asset is unique on NFTs, but in fungible tokens is not unique. So let's take an easy example for fungible tokens at first. Fungible tokens, we can say that fungible tokens, for example, is like money, like cash. So for example, when I give you uh, like a cash of $10 or $100, okay, and you give me another $100 paper, okay, so technically there is no difference because we exchange the same value between us, okay. So when we have this example, we can say that this example of fungible token. So for example, if we take like a real example of tokens. If I have one Bitcoin that I wish that I have, if I have one Bitcoin and one of you have a Bitcoin, I will send you to your wallet a Bitcoin and you send to me another Bitcoin to my wallet, to my address. Okay. So exactly we exchange the same value. So Bitcoin tokens and cryptocurrencies are example of fungible tokens. We can exchange them between each other, okay, and they have the same value. But NFTs are not all the tokens on NFTs have the same value. So, for example, let's take an example. Let's say, for example, the Mona Lisa. Okay, if I have the original copy of Mona Lisa, and someone comes to me and they have like another copy of Mona Lisa, I can't change the Mona Lisa between each other. Okay, the copy that I have and his copy, because exactly they don't have the same value. Okay, that's exactly the difference between NFTs and fungible tokens. So yeah, is that clear for you guys?
Yes.
Yes, thank you.
Okay, perfect. Perfect. Yeah. So let's continue for now. Okay. Okay. So Hedera provides us with like multiple services. The first one is the token service. So this service makes us able to create fungible tokens and also non-fungible tokens. Also, there is another service which is the consensus service on Hedera. So this service, it makes us able to create topics. So and we can use it to store all the messages or all the information that we want. So for example, We can use it to create a messaging application, for example. I can create a topic, okay, which means like a node, a special node. So that node, I can manage it. So I can say that only two addresses can like add messages to that node, okay? And with that, I can create like a chat application on top of Hedera. So I give the access to the sender and to the receiver. Only the addresses of the sender and of the receiver can write messages and can read messages from that topic. Okay, so yeah, that's exactly the idea. Also, the smart contract service on Hedera. So of course, if you create like if you have like a custom application that you need to build on top of the Hedera, so of course you need to create your own smart contract, okay, using Solidity, of course. So we use the Solidity programming language in order to create smart contracts or build smart contracts on top of Hedera. And after testing the smart contract, we can deploy it on the Hedera using the Hedera smart contract service. Yeah, that's our exactly the three services that you need to know. These services, you are going to practice it in the future sessions where you are going to see exactly how we can use token service in order to create fungible token or non-fungible token. Also, how to create a topic and how to send messages to the topic using the consensus service, and how to create smart contract and deploy it and like um, execute it. So you can call all the functionalities on that smart contract using the Hedera smart contract service. Yeah, perfect. Okay, so let's move on for now. Okay, now let's take a look on the governance on the Hedera network. So I just want you to know, guys, that the governance of the Hedera network are exactly the validators that Hedera select in order to validate the transactions on the Hedera network. So as we said before, that Hedera network is permissioned. It means that the validators are selected one by one. So Hedera network or the Hedera like team, they select their validators one by one, and this is an example uh, of the enterprises that are now validators on Hedera. So as you can see, there is a lot of known enterprises like Google, IBM, LJ, Chainlink, Tata, and there is a lot and a lot of other net or of other enterprises that are validators on the Hedera network. Yeah. Okay. So yeah, that's exactly why the Hedera network is permissioned. So they select the enterprises to be validators on Hedera. So just to be clear, guys, the functionality of the validator is only to validate transactions. It means that they listen to the transactions emitted by users. Okay, they treat them. They treat them like they test them if it's like a correct transaction or not, and after testing it, they can execute it or they can add it directly to the network. Okay, so and once it added directly to the network, it becomes impossible to change it or to delete it. That's exactly the idea. Okay. Also, now let's move to the next slide, which is like the features or the characteristics of Hedera network. So as I said, Hedera network is fast. Okay, so it provides us with 10,000 transactions per second. So Hedera network can like process 10,000 transactions per second. Okay, which is very fast, and it's like a huge number comparing with other networks, and we are going to see like a benchmark after that. Okay, also the Hedera network is secure. It's secure, so all the information are stored securely on the Hedera network. Also, it provides us the fairness, so we use the timestamp. So the feature of timestamp or the idea of timestamp is like storing the execution or every validator they will store when exactly they know about that transaction, when they hear about that transaction. And we are going to say after that in the demo exactly what we mean by timestamp and what we mean by registering the time of the transaction. Yeah. Also, it's stable, so it provides us with the stable price of executing or a stable price of fees. Okay, so as I told you, it's like around $0.0001 per transaction. Okay, so yeah. Also, I just want you to know, guys, that in each or in every network, a blockchain network, we mainly have three networks. The first one is the mainnet network. The second one is the testnet network, or the or buildnet network. Okay, they have two names, and the final one is the preview net network. So the mainnet network is the production network. Okay, it means that all the tokens circulating in that network are real. We are talking about real money in mainnet network. Okay, so for example, when we say in like the traditional development, when we say that we move to the production, so it means that the website is now live. Okay, and they all the users, they can access to it. In the Web3 world or in the blockchain world, when we say that we move in the production network, it means that we deploy our contracts and they are now executed on the mainnet network. So everyone can execute and can make changes or can execute transactions with those smart contracts on top of the mainnet network. Means that we are talking about real money here. Okay. Also, the testnet network is like created for developers like us. Okay, so of course we need to build and we need to test the network at first. Okay, uh, so we need to build it or deploy it on the testnet network at first. After executing all the tests and everything is going good, we can move to the mainnet network. Okay, so yeah, that's exactly why they provide us with the testnet network or the buildnet network. So it's like provided to the developers like us. Okay, and the preview net network is provided or specialized for the core development team of Hedera. So of course they always need to provide us with great features and improvements. So they execute their improvements on the preview net network. So and they test it locally in the preview net network. If it goes perfectly and if it works perfectly, they can deploy it after that on the testnet network and mainnet network. That's exactly the different types of mainnet, testnet, and previewnet. So yeah, it's really important for you guys. So is that part is clear for you? Is there any question?
No, it's totally clear.
Perfect, perfect, great. Yeah, let's move on. Now let's say like some comparison or some benchmarking with other networks. So as you can see, difference between like generations between the first generation is Bitcoin, as I told you, the second generation is Ethereum, and the third generation is Hedera. Okay, so the Bitcoin, it only like can process around 3, 4, 5 transactions per second, no more. Okay, um, the Ethereum is between 12 and 20 transactions per second, and Hedera is around 10,000 transactions per second. The fees on Bitcoin is really high. Okay, so it's around $22.57. Ethereum is around $20, but if the congestion on the network becomes very high,
Hello?
it means like if a lot of users use the network in the same time, the transaction fee can be like much more higher. It's like we can attend $130 easily, okay? And the transaction fees on Hedera, sorry. So transaction fees on Hedera are fixed, and it's always $0.001 per transaction. Also, the time of executing the transaction on Bitcoin is around 10 and 60 minutes. On Ethereum is around between 10 and 20 seconds, but in Hedera, it's more scalable. It's between 3 and 5 seconds. And also, as you can see, the energy consumed in order to add a new block on or a new transaction on the Hedera network. So yeah, as you can see, Bitcoin consumes a lot of electricity in order to add the transaction. Yeah, much less in the Ethereum network, but it's really incomparable with the Hedera network. So it's around 0.04 watt hour to add the transaction. So yeah, now let's like make some comparison with networks in the same generation. So yeah, when we say, for example, Polygon or Algorand are in the same generation of Hedera, okay, in the third generation. So Hedera always have more scalability comparing with other networks. So for example, Polygon, it can process around 6,500 transactions per second. The Algorand, it's only around 1,000 transactions per second. But Hedera, it's like, as I told you, it's around 10,000. The transaction fees on Polygon, yeah, it's look like cheap, but it's variable. It's not fixed. Okay. In Algorand are fixed with Algo, which means like the native token of Algorand. So it's not dollar. So for example, if the price of Algorand comes like increase, if the price of Algorand increase, it means that the transaction fee are going to be more higher. Okay, but with Hedera, it's fixed with dollar. Okay, it always $0.001 per transaction. Okay, so the time of the confirmation or the time of the execution of the transaction. So it in Polygon, it's between between 5 and 10 seconds. In Algorand, it's around 5 seconds, and in Hedera, it's more scalable. It's between 3 and 5 seconds. Okay, that's exactly the idea. That's exactly the benchmarking with other networks. So, and this is like a document or like an image that represents that Hedera is now the first one or the first transaction for now that can process transactions per second. The first one in ranking that can process the most transaction per second. Okay, so the first one is Hedera, the second one is Solana. These are like one of the leaders of the networks that already exist for now. Okay, okay, now let's move on. Okay, so for now, before like completing, I just want to see if everything's clear.
Yes.
Okay, perfect. Okay,
Yeah,
Grace
hello,
Satoshi.
I
Okay,
have a
I have some
question.
questions. Yeah, okay, go ahead.
Yeah, my question is that you say that on the side of transactions fees, compare BTC, Ethereum, and Hedera, you say that BTC takes almost like 10 minutes to 16 minutes. I would like just
Yeah.
to say that while in BTC, there are two layers. You may do transaction Lightning Network and takes even a second with no any fee anymore compared to the on chain.
Okay, but the transaction are not stored in the main chain.
Yeah.
So yeah, it's
It's a
it's
second
stored
layer.
on
It's a second
on
layer.
another layer. Yeah, perfect. Yeah, exactly. So basically, Gray Satoshi, all the layer twos technologies like Polygon, they are like they comes to life in order to make the transaction more faster. Okay, so for example, Polygon is a second layer built on top of the Ethereum network, and as you can see, as I told you, Ethereum network takes around 15 and 20 seconds in order to execute the transaction, but in Polygon is very fast. Okay,
Yeah.
that's exactly the difference. Okay, but
Yeah.
in that time, the transaction technically is not stored on the main chain, is not stored on the Ethereum directly. It's stored on Polygon chain, and after, for example, like I don't know, after 1 hour or something like that, all the transactions recorded in that time, they are going to be added automatically and directly in one transaction to the main chain. Is that clear, Grace Satoshi? Sorry, I can hear you.
Yeah, everything is it's good. I update you.
Okay, perfect. Thank you. Thank you,
Sorry
Mohammed.
to interrupt. Sorry, I was raising my
Okay, go
hand.
ahead. Yeah,
I
yeah, I'm sorry. Go ahead.
if is it possible, can you go back to the slide 15, I think,
Slide 15. Okay.
the one talking about energy consumption.
Energy consuming
Yes.
consuming
I
of the
was
energy.
asking
Okay.
about if, as far as I know, Hedera doesn't rely on mining. Is it true?
Yeah, yeah, of course.
So,
And all of those networks
yes.
in the slide, Polygon, Algorand, Ethereum, and Hedera, they don't rely on mining.
So I was asking about if the comparison between the fourth ledgers, is it about is all of them are relying or on mining or not? The thing is becoming clear now after what you said. Thank you.
Okay, perfect. Thank you. So yeah, we all those networks, Polygon, Algorand, Ethereum, they don't rely on mining. Okay, uh, Ethereum in the past it used to use the mining in order to execute transaction, but now it's no more using. We are not using mining on Ethereum. Okay, because it moved from proof of stake to proof of I'm sorry, from proof of work to proof of stake. Okay, so every network use the consensus of proof of work, it means directly that it used mining to execute the transaction. But if it used the proof of stake, we are not talking about mining anymore. Okay, that's the difference.
Yes, thank you.
Perfect. Okay, so is there any question? Any other question? Or I can move on. Okay, so Grace Satoshi just said you have a question about Hashback wallet after presentation. Okay, I will I will answer your question, inshallah. Okay, so let's move on.
Yeah. It's sorry. Can you
Okay.
ask the question?
Okay. I can answer to your question after the presentation, as you said. Okay.
Okay. Thank you very much.
Okay. Perfect. Uh, okay. So now, this image or this presentation uh, proves or like demonstrates all the ecosystem of Hedera, starting from the users to the network to the services provided to Hedera, and ending by the network, means the mainnet network. Okay, so as you can see, this is the mainnet network, okay, where all the data are stored. Okay, so this network always listen to the services provided by Hedera, so which are exactly the consensus service, the token service, the smart contract, and the smart contract service. Okay, so if one of the transactions come from one of those services, it means that it's going to be changements or the new transaction are going to be executed on the mainnet network. Okay, so who controls this part? Okay, so as I told you, the Hedera Governing Council, which are exactly the validators like selected by the Hedera network. So the Hedera councils, they listen to the transactions, okay, comes from the consensus service, token service, and smart contract service. They trade them and they directly store them on the Hedera mainnet. Okay, yeah, that's exactly the idea. So, and we can build applications using those services. Okay, so for example, I can like create an application for identity that creates identity, an application for make some tokenization, an application of payments, all the type of the application that I want. I can build it using those services. Okay, so yeah. And who use those services or those applications? Of course, the end users, individuals, enterprises, governments, and also IoT devices. Yeah, that's exactly all the ecosystem of Hedera and how we link all the parts in Hedera. Okay, perfect. Now let's go and let's say so. This is like the blockchain. Okay, this is a blockchain. So as you can see, these are blocks, and each block it contains like data, a previous hash, and the hash of the block. Okay, and the next block always stores the previous hash to make the link between the two blocks. Okay. Okay, now let's not focus more on blockchain. We just need to focus on the hash graph, okay, to understand the technology of Hedera. So yeah, as I told you guys, now we are going to make a demo, okay, how the transaction are processed or how the transaction is yeah, the workflow of the transaction between validators, okay? So for example, let's say that Alice, Hank, Gina, Frank, and all of those are validators on Hedera. So for example, let's say that a transaction comes to Alice. So Alice detects a transaction from one of the services, okay? So what it's going to do, what Alice is going to do, what she's going to do is to gossip the transaction. What you mean gossiping the transaction is telling other validators that this transaction comes to the network. Okay, so yeah, so for example, Alice is going to tell Dave that the transaction comes to the network. Okay, that it detects the transaction. Okay, so now technically, who have the transaction? It's Alice and Dave say at the same time. Okay, both of them they know about the transaction. After that, Alice is going to send to Gina, and Dave is going to send to Bob. And after that, all the other validators are going to gossip the transaction. So as you can see, that the transaction are distributed or gossiped exponentially. Okay, it's very fast sending or telling the transaction to all the validators. Okay, so and this process makes the transaction very fast in hash graph technologies. Okay, so because one of the important part in distributed ledger technologies is to distribute the transaction to all the validators. All the validators needs to have the same copy of the ledger. Okay, so we all the validators needs to know about the transaction. So the way used by Hedera is to gossip the transaction in an exponential manner. Okay, yeah. So now let's take another example. The case of adding two transactions in the same time. So for example, if Bob detects a transaction, the green transaction, Carol detects the blue transaction in the same time, so they are going to execute the same process, which is gossiping the transaction. Okay, so now you are going to gossip. Bob sends to Frank and Carol sends to Gina. Then we are going to continue the gossiping the transaction, and after that, after executing all the gossip, all the validators now they have an idea about the transactions. But guys, there is a problem here. We are facing a problem here, which is like the order of the transaction. So as you can see, Alice, the order of the transaction is red, green, blue. But with Bob is blue, red, green. So we need to order the transactions in a manner that all the validators have the same order. Okay. So to do that, this is the part where Hedera used the fairness. Okay, so all the validators they like register the time of hearing about the transaction. Okay, and after that we can like select all that timestamps, and we can order them, all the red ones, blue ones, and green ones. Then we are going to detect the like the intermediate one. Okay, so this one is going to be selected and it's going to be like chosen as a reference. Okay, so we are going to order this transactions depending on those times. Okay, so and depending on that we can now have the correct order, which is red, blue, and green. Yeah, that's exactly the idea, and this is like exactly the demo, and you are going to see in the right part when we execute the gossip. Okay, so Alice, it have the transaction, it send it to Dave. So in that time Alice and Dave have the transaction. Okay, then Dave sends to Bob and Alice sends to Gina. Now the four of them, they have about the transaction and they know about the transaction. And finally we can see this architecture of a hash graph. Okay, of hash graph. Okay, perfect. That's exactly the demo. So yeah, we are almost in the end. So as I told you guys, so Hedera is a public and permissioned network. Okay, but in the future they are aiming to be public and permissionless. So one of the example of other projects, so public permission network, one of the example is Ripple. Okay, they have the token of XRP. Okay, and the most and the perfect example for public and permissionless can take Bitcoin and Ethereum, as I told you before. So Hedera, they are aiming to move from public permissioned to public permissionless. Okay, also there is private permissioned network, so like as I told you before, it's like Hyperledger. And for private and permissionless, we can say Holochain and Money is one of the networks or the leaders in that part. Okay, now so Hedera is now in that part, so in this part or in this stage, in staking part. Okay, so everyone can stake their tokens on Hedera. Okay, and of course we are going in the future they are going to move to add some more validators using KYC, which is the concept of know your customer. Okay, we can add some validators or nodes to the Hedera network, and the goal or the main goal is to be 100% permissionless. So anyone can be in that time a validator on the network. Yeah. So also, as you can see, these are the current validators. This is the phase one, the current phase that we are living now. Okay, so Hedera have 39 council members for now, and those 39 council members, they are like located all around the globe. Okay, so as you can see, from America to Africa to Asia and Europe and all of those continents. Okay. No, the second part is to adding the KYC. Okay, add the KYC validators, and the final phase is the permissionless phase, okay, where anyone in the world can be validator on the network of Hedera. Yeah, that's exactly the presentation. Thank you, guys. Thank you for attention. Okay, so do you have any question? Okay, I think that there's a lot of questions here. Okay, hello, here are my questions. Okay, I'm going to start with you. What is Hedera hash graph and how does it differ from traditional blockchain technology? Okay, so the first like difference between Hedera and other networks or other blockchains. So the first thing is that Hedera didn't use the technology of blockchain. It used the technology of hash graph, as I show you in the demo. So they store the information or the transaction in a fast manner using the technology of gossiping. Okay, the transaction between all the nodes. Okay, so what is the role of the Hedera Governing Council and who are its members? Okay, so the Hedera Governing Councils are the validators on the Hedera network. Okay, so the validators, they have the role of treating the transaction before adding it to the main network. Okay, that's exactly the role of the Governing Council. Okay, and their members, as I show you, a lot of enterprises like Google, IBM, and Chainlink, and they are located all around the globe. Okay. Third transaction, how does the transaction consensus algorithm achieve fast and fair transactions ordering? So yeah, using the gossiping and using the fairness. When we use the gossiping, the exponential gossiping and the exponential distribution of the transaction, we ensure the rapid transaction execution, and also using the fairness to order to the transactions one by one. Okay. Fourth question: what are the main use cases on the Hedera network in real-world applications? So, as I told you, we can create a lot of applications on top of the Hedera network. So, for example, I can like build any type of application. I can build like a DeFi application where everyone or every user can make some exchanges with pools. For example, I can create pools where users can trade other currencies on top of that application. Also, I can like create an application for my enterprise. I can create all the type of the applications that I want. Okay, yeah. Also for like gaming application, I can use it. I can build some game application on top of the HBAR. I can create like a chat application on Hedera. Yeah. Where's the hashbar token used for the Hedera token ecosystem? So the hashbar token is the native token of the transaction. Oh yeah, of the network. So if you want to execute any transaction, you need to pay fees using the native token of that network. So, and the native token of the Hedera ecosystem is the hashbar token. Okay. Yeah. How does Hashgraph ensure security, and what does it mean by asynchronous Byzantine fault tolerant? Okay. So Hashgraph ensures security by using the consensus and using all the cryptographic principles. Okay. So to be honest, uh, if you want to dive more deeper into that system, it's going to be more difficult. Okay, but yeah, I really like love if you go more deeper into that concept. Okay, but for now, if you are going to develop or doing something like that, you don't need to know about all of those transactions. You just need to know that the ecosystem and the code of Hedera, it ensures to you the security of your transaction or of your data. Okay, stored. Uh, okay, go ahead, Mariam. Miriam, can you hear me? Okay, I'm not sharing my screen. I think the questions are in the chat. Okay, I'm answering the question on this chat. Also, I think the document that I present to you, it's going to be shared, I think, by Talel, by the team of their blockchain. Okay.
Yes, just 1 second, and it will be shared on the chat.
Okay, perfect. Perfect. Thank you. Thank you, Talel. Okay, so yeah, let's continue answering the questions very fast. Okay, so what advantages does Hashgraph offer in terms of scalability and energy efficiency? So yeah, as I told you, we offer the Hedera network offers like a huge number of TPS, okay, which is transaction per second, greeting the transaction per second. It's around 10,000. Also, it's like provide us with the execution time of the transaction. It's between 3 and 5 seconds. Also, the fees of the transaction is around $0.001. Comparing with other networks, it's very very cheap. Okay, that's the scalability of Hedera. How does the Hedera network handle smart contracts, and what makes them different from Ethereum's? Okay, so to be honest, to develop your smart contract on Hedera, you need to use the Solidity. It's the same programming language when you are going to deploy on or to build on top of the Ethereum. Okay, so there is no difference in developing the smart contract. Okay, it's the same process or the same language. Okay, but when you are going to deploy the transaction on the network, you are going to use the Hedera smart contract service. And also, if you want to communicate with your smart contract that is already deployed, you are going to use also the Hedera smart contract service. That's exactly the difference. In the Ethereum network, you are going to use like the APIs of, for example, Ethers GS or Web3 GS in order to communicate with the smart contract or with the blockchain. Okay, but in the Hedera ecosystem, you are going to use the services like the Hedera token service, the Hedera smart contract service, and the Hedera consensus service. That's exactly the difference between the both of them. Okay, now let's move on. The number 9, can developers build decentralized applications on Hedera? Of course, of course. It's like all the other technologies or all the other networks. You can build decentralized applications on top of the Hedera, and that's the main goal: developing decentralized applications. 10. What are the challenges facing Hedera Hashgraph in gaining mainstream adoption, and how are they being addressed? Okay. Oh, so it's a great question. So the challenges of Hedera. So Hedera are focusing on the I don't know if you know it's the CBDC's tokens. Okay, just 1 second, guys. Okay, and I will come back. Just 1 second. Okay, I'm sorry, guys. So I just okay, I just talk about the concept of CBDCs. So the CBDCs are like central bank decentralized coin. That's what I mean by CBDCs, and it's like a concept of tokens manipulated by banks. Okay, yeah. So as you know, the tokens for now and the cryptocurrencies are like 100% decentralized. There is no one single entity, they can control that token. Okay, so that part that makes a lot of difficulties for banks. Okay, so that's why they introduce the concept of CBDCs, and I think Hedera, they are focusing on that part, and that's why they make a lot of partnership in Qatar and in Dubai in order to achieve that goal. Yeah. So the adoption is going to be like step by step more adopted, this network. Okay, I believe it's a huge network. Okay, and it's not me that talks about this network, the community of the Hedera network, and also you can like check the the social media, and you will be sure that this ecosystem is very huge, and they are going to make a lot and a lot of advancement in the future. Okay, yeah. The next question: what is the key consensus algorithm used by the Hedera network? So basically, the most known, which is the I think it's the staking, which is proof of stake. Okay. What are the main services provided by the Hedera network? So the main services I told you, the Hedera token service, the Hedera consensus service, and the Hedera smart contract service. How does the hashgraph consensus mechanism ensure fairness in transaction ordering? So as I told you, when any validator detects the network or the transaction, they stores the time of detecting this transaction. Okay, and after that we're going to make like to select the intermediary one and like choose it to be the main time. Okay, so let's move on. What are the main services? Okay, just what role do Hedera governing council members play in the network? So as I told you, the role of the governing councils are the validators. They validate the transactions that are going to be stored on the network. So they validate it, they check it if everything is good with that transaction, and if everything is good, they are going to store it on the mainnet network. Yeah. What is hashbar used for the Hedera ecosystem? So hashbar is the native token to pay fees. Where is the difference between Hedera token service and Hedera smart contract service? So the Hedera token service, it's a service that provides you the ability to create tokens, fungible tokens or non-fungible tokens, and smart contracts. If, for example, you have like a custom application to build, you need to create your own smart contract. So to deploy it, you need to use the Hedera smart contract service. That's exactly the difference. So number 17, how the mirror nodes differ from consensus nodes. Okay, so the mirror, just I need you to know this information. When the transaction is stored on the mainnet network, if you want to get it in the same time, you are going to pay some fees. Just to be clear for you guys. But if you are going to wait, for example, 8 seconds, it automatically are going to be stored on the mirror node. This node is a special node, okay, where all the transactions are stored, okay, and you can read all the information from it in free manner, okay. So we are not going to pay if you want to pay. If you want to read any information, you need to always read from the mirror network. Okay, the mirror network provides you the ability to read information freely. Okay, in a free manner. Okay, what is the purpose of the get receipt? Okay, so the purpose of the function get receipt. Yeah, it's technicals. These are technical questions. So get receipt, it gives you the status of the transaction. So get status, it gives you like the status if the transaction was executed successfully or not. Okay, if it's failed, it's going to fail. It's going to show you fail. Okay, and if it was executed successfully, it's going to show you succeed. Okay, that's exactly the goal or the role of the get receipt function. Okay, why the Hedera considered more energy efficient than traditional blockchains like Bitcoin and Ethereum. Yeah. So as I told you, the Bitcoin use mining and use proof of stake. I'm sorry, proof of work in order to execute transactions. So that's mainly the first thing that makes the Bitcoin network consumes a lot of energy in order to execute the transaction. But the Hedera network doesn't use mining, it doesn't use proof of work, and the manner of distributing the transaction between all the validators, it's really cheap, so it doesn't go on to consume a lot of electricity. That's exactly the answer. Okay, so for the presentation. Okay, thank you guys. Thank you for your attention. Thank you for your kind words. Okay, okay. So what is the Hedera hash graph and how does it differ from traditional blockchain technologies? Oh, okay. You are answering the question. Thank you. Thank you, Mariam.
Yeah, thank you very much for the amazing answers.
Thank you. Thank you. You're welcome. You're welcome. Great Satoshi.
And
Much.
sorry, my other question, is
Okay,
that
yeah.
I just did hash graph exams, and at the end I received my certificate. And then after they need
Okay.
me to have I
Congratulations.
downloaded the hash. Yeah, I downloaded the hash graph, not
Okay.
Hashpark wallet. Then on the side of minting, how can I mint the NFT that I was told to mint after
Okay.
finish the
Okay. So perfect. Perfect. Thank you. Thank you, great Satoshi. So in order to mint your NFT, you need to have some tokens, some HBAR tokens on your wallet. Okay. And also you need to connect or add your address. I don't think so. I'm not sure. So to connect your wallet or add your address where you are going to execute two transactions. So at first you need to accept the ID of that NFT, and then they are going to send to you your NFT. So the first thing that you need to do is to have some HBAR tokens in your wallet, and of course you have the feature of um, downloading your uh, your certification in a PDF. Okay.
yeah.
Okay, perfect. So in order to mint your NFT in your wallet, it becomes it means why we say minting. It means like creating your certification or becomes an NFT in your wallet. Okay, so your address will own that NFT. Okay, so to do that, at first you need to have some HBAR tokens in your wallet. That's the first thing that you need to ensure, and after that, you will execute a transaction, I think, to accept that token in your collectibles, and then they are going to send to you and mint to your NFT. Is that clear for you, Satoshi?
Yeah.
Satoshi.
And the other question
Okay.
is that when on those modules, those there are almost like 11 modules. On the second module, there are some of the
Okay.
questions whereby on the second module, there are some of the questions whereby then multiple choices are repeatedly, or you might find both of them are the same answers to the question regard, or maybe the question has a mistake. So there are some of the modules that are actually you guys need to get some review and do some correction on some of the questions.
Okay. You can send me the question on the responses, and I'm going to check it. Okay.
Yeah.
Okay, thank you. Thank you so much, Grace Satoshi.
Thank you.
Okay, so is there any other question?
No question. Hedera is amazing project. I really love it.
Yeah, great. It's really, I'm really happy to hear that. So yeah, keep moving, guys. I think you have like the platform where you are going to see all the videos. So this is an introduction for the Hedera network. So I don't think so. Talal, are you here? Don't think so. He's not here. Okay. Thank you, everyone. Thank you for attending this session. I hope that you understands very well the ecosystem of Hedera. Okay. Keep going, keep moving, and go and take your certificates. Thank you and goodbye.
Thank you. Goodbye.